Is your unit circle review, and right off the bat it says use your calculator. Okay, so 3.3, easy question. Degree mode or radian mode? What do you think?
Radian mode.
I don't see a little degree symbol, so it's got to be radians, right? So the first thing I'm going to do is check my calculator mode. Okay, so I'm going to go, okay, wait a minute. If I'm going to use my calculator, I better be careful. I'm going to need radian mode, right? So I'm going to go to my calculator. I'm going to go turn it on, clear, quit, check my mode, and I'm in degree mode. I need to put it in radian mode, okay? So the first thing I'm going to do is change it to radian mode, okay? So then it's pretty easy, okay? So cosine of 3.3. You cannot miss this question unless you're in the wrong mode. You guys agree? Cosine 3.3 is, yeah, negative 0.987, right? Let's try and go to the nearest thousandth if we can. Negative 0.987. Easy, right? Cotangent. Now do cotangent. I might. Yeah, so we're going to really do on number 2. Let's see, I'll do it on a separate sheet of paper. I'm going to do for cotangent of 4.2. We're really going to go tangent of 1 over 4.2. Does that make sense? Okay, because there is no cotangent button, but it is 1 over tangent. So I'm going to go tangent. Hold on, what's wrong with me? Tangent 1 over tangent of 4.2. That's what I want. Yes. 1 divided by tangent of 4.2. That's what I want. I'm not looking for the angle. I have the angle. So I got about a 0.562. So it's 1 over the angle. That is an angle. Sorry to confuse you for a second. That's the inverse. We're not doing the inverse, okay? So it just, because cotangent theta is 1 over tangent theta, and that's where we get our identity from, okay? All right. 3 secant of negative 1.2 is the same thing as 1 over cosine of negative 1.2, okay? So we're just going to use our calculator. So I'm just going to go 1 divided by cosine negative 1.2, and I get about a 2. Oh, if I round, I'd have 2.760, right? There, if I round to the nearest thousandths. How am I doing? Okay so far? Okay. These should be pretty easy. Sine of 3/4. Sine of 3/4. It's easy, right? We're just going to go sine 3 divided by 4. And I get about a 0.682. About a 0.682. Okay? Not too bad. Now, where kids are going to have the hardest is these next ones are the hardest. So these are the ones everybody misses, but not you guys. We're not going to miss these at all, okay? It's the reference angles, okay? We're going to draw a picture. All right? So do the reference angle. Number 7. Okay? Oh, number 5. 7 pi 6. So, thanks, Marie. I need a reference angle, right? So let's see. On our unit circle, 7 pi 6 is here. Okay? So I want to create a triangle within that, right? So the triangle I'm looking at, if I just draw a cute little picture, looks like this, right? Now, we need it in terms of radians, but we can go ahead and get it in degrees first, because we know that's a 30-degree angle, right? So our reference angle, theta, really is 30 degrees. And if we were doing degrees for dummies, we'd say the answer was 30, but it's not. It's pi 6. Same thing, right? The equivalent of 30 degrees is pi 6, okay? Everybody okay with that on the reference angle? So my answer is pi 6 is my reference angle, or my reference number. The book likes to call it a number, reference number, okay? So you just make your triangle, and you're looking for the triangle that is flush with the x-axis, and what is the angle of rotation from there, okay? Let's look at 6, okay? 6 is negative 2 pi thirds, negative 2 pi thirds, and If I go to my circle, positive 2 pi thirds is here, right? Positive 2 pi thirds is here. So negative 2 pi thirds is right there. So negative pi thirds is right there, okay? So I'm going to try and draw a triangle, okay? Do you see the triangle I'm going to draw? Try and draw that triangle right there. So I'll just make a quick little sketch out of it. The triangle I'm looking for is right here. Now, that's a 60-degree angle, right? So that's my reference angle. Okay, it's the angle, the acute angle. It's the acute angle that creates the triangle, okay? But it's got to be flush with the x-axis. So 60 degrees, theta equals 60 degrees, but degrees for dummies, right? So we know that the equivalent radian for 60 degrees happens to be pi thirds. So we want the pi thirds answer, okay? So theta is equal to pi thirds. That's my reference angle, or like the book likes to call it, the reference number, okay? Hold on. Hello? Yes. Yes. Yeah, I think Gabe's on the choir tour. Isn't he on the choir?
Mm-hmm.
Yeah. But I am also taking Isaac. I didn't put Isaac on my name. And Chase Lord. Yeah, but I think Gabe's off on the choir thing. Right. She's on choir. She's on choir. Taylor's not going. Will is not going because he's going tomorrow. No. Danny's not going. No, Arthur's not going. Erin's not going because she's too good. Who? No. Danny Polson? No, Danny's not with us.
Dan? He does tennis.
He's
He's in
tennis.
tennis.
Dan.
Yes, but Danny's not school, I think.
You're going to tennis?
Oh, I didn't know that. So, yes on Stephen, no on David. So David's off on class. Thanks, Lori.
Get out.
All right, back to math, huh? Sorry about that. Whoever's watching this recording, we had a temporary little delay. Okay, number 7, huh? 7. Okay, 7's a little bit tricky. 5.5, okay? So, here's how you got to do it. This is 3.14, because that's pi, right? I think this is a 4.7. I'll double check, but 3 pi halves. 3 pi halves. We'll double check the decimal, okay? So let's double check 3 pi divided by 2. That's about a 4.7. And this would be a 6.28 as far as decimals, right? You guys with me? Okay, so I just put the decimal equivalents for pi, for 3 pi halves, and for 2 pi. Those are the decimal equivalents. So 5.5 is probably somewhere around here. Does that make sense? That 5.5 would be right about there somewhere, because it's got to be between these two, right? 5.5, okay? So what happens is we get this triangle right here. So you see the triangle? So if I need this reference angle, I'm just going to take 6.28 minus 5.5, wouldn't I? Okay, you can see it, can't you? So if I go to 6.28 minus your 5.5, I get what's left over, which is that angle right there. So clear, let's go 6.28, subtract 5.5, and I get an answer about, answer about 0.78. So my reference angle is 0.78, or reference number. Okay? Alright, let me throw that, turn the page whenever you're ready. Okay, ready, set, turn the page. Okay, number 8, again, is another little tricky one. We've got -2, so let me do the same thing, right? So if I go backwards, right, this is, let's put this as 0. And then if we go negative pi halves, I'm going backwards, okay? So if I go negative pi divided by 2, that's a negative 1.57. So negative 2's got to be right about there, okay? Negative 2's got to be right about there. Okay, now, what I'd like to do is change this to a positive value. Because if I go negative 2 this way, and I'll go slowly. If I go negative 2 to here, if I went this direction, it's the same spot, right? If I go either back it up or go this way. So if I take 2 pi and add it to my negative 2, I'll get this angle, okay? You all right with that? Okay. Instead of going backwards, let's go all the way around to it. So I'm going to go 2 pi and add to the negative 2. So if I go 2 pi on my calculator, 2 pi subtract 2, I get a decimal about 4.28. So really, 4.28 is about the same as negative 2, okay? So where is 4.28? Well, this one was 4.7, wasn't it? Right here. So 4.28 is right about there, okay? So how do I get this reference angle, okay? So I get this triangle right here, okay? And I want this angle right there, okay? Am I going too fast? This one's hard. I want that angle there. So this is pi, and this is 4.28. So if I take my 4.28 and minus pi from it, because that's 4.28, minus pi gives me what's left over. I'll get this reference angle here, okay? So we'll go 4.28 minus my pi, and my reference angle or number is about a 1.14. So I get about a 1.14. Okay?
Wait, could you go back?
Yeah.
Did you get the 1.4?
1.14?
Yeah.
Right there.
Oh, okay.
Right, so let's do it in degrees. You'll see it if I do the whole thing. Let me scoot it and you'll get it if I do it in degrees, okay? Let me just do degrees. Let's say theta equals negative, let's make it negative 200 degrees, okay? So negative 200 degrees would put me right about here. You right? Does that make sense? No, more than that. Sorry. Let's use something besides negative. Let's go negative. Let's go negative 100, okay? Let's go negative 100 degrees. Does that make negative 100 degrees? Or I could go this way, which would be 360 minus the 100, which would put me at 260 degrees, okay? So go with the analogy, okay? Negative 100 is backwards, or positive 260 is this way, okay? So that's the first thing I did. First thing I did is I changed the negative angle into a positive angle. So in this case, I took 360 minus that 100, okay? With decimals, with pi's, it doesn't make as much sense because it's pi's, right? So negative 2 could be converted to a positive angle by taking 360 minus that, but not 360, but 2 pi minus that, okay? So I get, what is 2 pi plus a negative 2? That's my 4.28. So this angle is a 4.28. This angle here is a 4.28, just as this angle here is a 260. All right? Then, to get this reference angle, I would just take and subtract I would take the 260 minus the 180, right? 260 minus the 180 would give me the reference angle. Doing the same thing. I'm taking the 4.28 minus the pi gives me this reference angle, okay? This one's hard, okay? This one's a little bit harder. But most of the test is pretty easy, okay? Okay, let's move on. All right, here comes the easy stuff. Number 9. Terminal point, 5 pi 6. All right, unit circle. Yep. But what's the point? So we go to the point. 5 pi 6 is here. It's that point. So we're going to actually write the point. There's 5 pi 6. We're going to write negative square root of 3 over 2, 1/2. That's the point. So what's the point at 5 pi 6? That's it right there. Number 10. I've got a 20 pi thirds. 3 goes into 20. 6 times with 2 left over, right? You guys agree with that? 3 goes into 26 times with 2 left over. So let's take a journey, right? 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, and then I need 2/3 of a pi. Puts me right there. So there's my terminal point at negative 1/2 square root of 3 over 2. Okay? 11. Negative 5 pi 6. So 5 pi 6 is this rotation, right? 5 pi 6 this rotation. Negative 5 pi 6, same rotation but backwards, puts me right here at 7 pi 6. My terminal point is that one right there. negative square root of 3 over 2, negative 1/2. Okay, does that make sense? Everybody good on that? Okay. Another trick, if you totally don't get it, ready? You want to see a trick? I'll show you a nice trick. Negative 5 pi 6. 5 pi 6 is in degrees, ready? 5 pi 6 in degrees is 150, okay? So if you had a negative 150 degrees, add 360 to that answer, what do you get? Just showing you another way to do it, okay? Negative 150 plus 360 gives you a 210 degree angle. So go to your 210 degree angle, boom, same thing. Now, a nice little trick. So if you do it in terms of degrees, it's easier, isn't it? There's all sorts of tricks up there. Okay, 12. Here comes the fun stuff. This is stuff we're good at, okay? Turn the page. 12. Here comes the easy stuff. 12. We want sine of pi halves. Okay, pi halves is the y value. We got a pi half. Sine of the y value is 1. There it is. Answer is 1. Capiche? Of course. Easy. Easy squeezy, lemon peasy. Number 13, we've got cosine of 5 pi thirds. X value, 5 pi thirds is there. X value is 1/2. Oops, screwed up. 1/2, okay. 14, tangent, 7 pi 6. Yep, 7 pi 6 here. Tangent values are on the outside. I don't have them on this one, but it's square root of 3 over 3. It's on the board though. Square root of 3 over 3, right? Everybody good? Thumbs up. I'm not going too fast. Okay. Dylan, you with me? Good. 15. We've got cosine of negative pi thirds. Okay, so pi thirds is there, right? Negative pi thirds is right there. And you can do the same trick with degrees if you want to, but negative pi thirds here. We're looking for the cosine, which is the x value, which is 1/2, right? Capiche? I like it. 16, secant of 5 pi thirds. So secant's 1 over the x value. So let's go to 5 pi thirds and figure out what the x value is, okay? So 5 pi thirds is there. The x value is 1/2. So it's just 1 over 1/2. We flip our fraction and make it 2 over 1, which is just basically 2. We can do this. 17. I have cosecant of 3 pi fourths, which is 1 over the y value, right? So 3 pi fourths is here. The y value is square root of 2 over 2, so I'm going to have a 1 over square root of 2 over 2. If you flip it and if you rationalize it, it is just the square root of 2, okay? Okay, we've done that. I've shown you how that works, right? 18. 18 is cosecant negative pi halves. Cosecant negative pi halves, which is 1 over the y value. So negative pi halves.
You're doing 19.
Am I doing the wrong one?
You're doing 19.
Oh, doggone it. Okay, let's do 18. Thanks, Marie. 18, cotangent of 2 pi. Thank you. Okay, cotangent's going to be the x over the y, okay? The x over the y, 2 pi. That's right there. X over y is 1 over 0. It's going to kick your asymptote, right? Undefined. It's 1 over 0, undefined. Okay. 19. Now let's do cosecant of negative pi halves. Cosecant's 1 over the y value. Negative pi halves is right there, right? Right there. So I'm going 1 over the y value, which is 1 over negative 1. 1 over negative 1, which is just negative 1. Okay. Thumbs up, 2 thumbs up. Easy, right? Should be an easy quiz, I'm hoping, okay? Turn the page. Let's do number 20. Okay, now this is going to be one of these things where you can miss a whole lot of points, or you can get them all right, okay? So, tangent. Theta is equal to 7/24, okay? So what we're going to do is this, and it's in quadrant 3, okay? So do your axes. Start right off the bat with that, okay? Do your axes, okay? And then if we're in quadrant 3, put a triangle in quadrant 3, okay? Put a right triangle in quadrant 3, okay? Start with that, okay? Now, what we know about tangent is equal to the opposite over the adjacent, right? So opposite has got to be the 7, and the adjacent is 24. But be careful. Be careful. It's really, everybody watching? Everybody? It's a -7, -24. Has to be. Because you go over and back. Now the reason it comes out as positive, because in the fraction, the two negatives cancel each other out. Does that make sense? The -7 over -24 cancels out in this, but it has to be negative, okay? Now we need this side, right? We need the radius, so we're going to use Pythagorean's theorem. Easy, right? I'm going to go 7 squared plus 24 squared equals c squared, right? Let's use my calculator, huh? Let's just go 7 squared plus 24 squared, square root that answer. I get 25, right? So c is equal to 25, which is really the radius. Zane asked this question a little while ago. The radius is always positive because it's a length, right? So 25. Okay, now let's set everything up. Okay, so right off the bat, we can do sine of theta. Well, sine is opposite of hypotenuse. -24 over 25. That's your answer. Cosine is adjacent over hypotenuse. -7/25. Easy, right? Tangent's done. We don't need to do tangent. Let's do cosecant of theta. Cosecant of theta is the inverse of sine. 25 over -24. Yeah. Secant is the inverse of cosine, or the cofunction of it. So it's just 25 over -7. And finally, cotangent of theta is the reciprocal of tangent. So it's going to be 24 over 7. 2 thumbs up. Super easy, everybody agree? 2 thumbs up. Zane. Yeah. Got them all? Squish them all in. Okay. Cross my fingers. It's an easy one tomorrow. Gerardo.
Which one was it, adjacent?
Right, so if you take a look, the angle is here, right? The angle's here, right? So if I'm at the angle, that would be its opposite side because it's directly opposite, right? You got it? Remember that? And that makes the 7 the adjacent, and then that's the hypotenuse, right? Okay. Okay, should we shift up? Oh, we're going to need some graph paper. Okay, I got to find some graph paper, right? Let's see what I can find. Graph paper. Do I have any graph paper? I do.
If you have time today, can you do it?
Maybe, yeah. Okay, number 21. Let's do 21, okay? 21, graph. Y equals -3. Oh, that's supposed to be a cosine. I can't type, can I? Of a 3 theta. Okay, so when I do these, this is my hint, is I look at what the cosine graph looks like. And you can use these tomorrow, okay? You can use these, okay? So what does a cosine graph look like? It looks like this. So I'm going to put a little mini picture down and say, okay, a cosine looks something like this. Just a picture of it so I know what it looks like, okay? So I need to take this shape and graph it, okay? So get my ruler out. I know a few things for sure. I know it's got an amplitude of 3, right? Yeah, so for one of the things I'm going to do is go, 3, -3. Okay? Don't miss this next part. Normally, I go pi halves, pi. Normally I go pi halves, pi, 3 pi halves, but I'm not. I'm going to go in terms of thirds, okay? I'm going to go in terms of thirds. So I'm going to go pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds. Let me scoot it over some more. 5 pi thirds, 2 pi, okay? How am I doing? Pretty good? So I need to take this shape and fit it in there. How do I know there? Because I'm going to take my 2 pi, which is this normal 2 pi here. I'm going to take my normal 2 pi here, and I got to break it up into 3 parts because I need to get 3 graphs in. Okay, I'll say it again. I need to get three graphs within 0 to 2 pi. So I got to take this 2 pi and divide it in thirds. That tells me that each graph is going to be 2/3, another 2/3 pi, another 2/3 pi. So I get all 3 of them in there. Okay. So here it is. But with one small exception, upside down, right? It's got to be upside down. So it's really going to look like this. Okay. It's going to start here and it's going to end here for one full curve, right? See how that works? At pi thirds, it's going to be up here. It's going to go through the x-intercepts at pi 6. Okay, so one full curve looks like this. Okay, there's one of them, and let's put in the other 3. So I'm just going to repeat the pattern here. Starts down, ends down at pi. It's going to be up at 1. Has its x-intercepts here and here. Okay. Starts here, ends here, up there, okay. Okay, there it is. Not too bad. Thumbs up. Thumbs sideways. Thumbs down. Okay, all right. Okay, let's start. The nice thing about this is that almost all of this test is easy, agree? If these are the only 2 hard ones, then most of this test you got, right? Okay, let's look at 22, right? 22 is a little bit more complicated, but we're going to do it. Okay, 22, I've got a y equals a 3 cosine 2 theta minus pi force plus 2. Okay, a couple of things I do know. I'm going to go from 2 to -2, right? I know that for sure. Because the amplitude, oh, did I say 2? I meant 3. 3 to -3. Because the amplitude is 3. Okay, I know that. I know the basic shape of a cosine. We just looked at it. You know, the basic shape of a cosine. If I look at my little graphs, cosine looks like that, right? So that's the shape. So I like to just put a little squiggly. That's the shape I need. There it is. I need to take that shape right there and graph, okay? Now, I need 2 curves. So I'm going to do my pi halves, my 3 pi halves, okay? So I'm going to go my pi halves, pi, 3 pi halves, 2 pi, okay? I'm going to do it in 2 parts, okay? First part I'll put in pencil, okay? First part I'll put in pencil. I'm going to graph this part first, okay? And then I can move it. So first let's graph just 3 cosine of 2 theta. So I want this shape here to go 1, 2 of them. To get 2 of them I'll have 1 here, second one here. So I got to get 2 curves. I'm going to have 1 here, 2 here. So that means if I take the normal 2 pi and divide it up in 2 parts, each part would be a pi, right? Alright, so it's going to look like this. Cosine starts there, ends there. It's down at -3 there, at pi halves. Okay, there's one curve. Between 3 and -3, okay? I'm going to do it again because I need 2 of them, right? Okay, so I have 2 of my curves. 2 of my curves, right? Got 2 of my curves. So in order to get 2, it's between 0 and pi and between pi and 2 pi, okay? Now, the easy part, we're going to move them, okay? So let's move opposite direction. We're going to go opposite, so we're going to go that way, okay? Okay, we're going to pi force to the right and then up 2, okay? So pi force is 2 squares, right? You guys agree? Pi force is right here.
You said it down.
Sure. How's that? Is that about right? So pi force is really 2 squares, so I'm going to move it 2 squares and then up 2 squares. So take every important point. 1, 2, 1.